In the previous part, we discussed how to create our own objects, our own vectors, and how to use those vectors with some basic functions or some additional functions like causae. Now, we will talk about how to create your own function. Yeah? And in particular, suppose that we are interested in writing such a function that randomly generate the result of one roll of a die. It checks what bone we sample, yeah, and we want to and I want to create such a function that sample two rolls of two dice randomly, and then it sum the realized outcomes. Yeah, so to this end, we will create a function. Yeah, the name of this function is roll2, and in R we define function using this. Yeah, using command function. So I'm saying that every time I type roll2, I want to run function, and here I provide arguments for those functions. Let's say bonds, yeah, and here I provide the default argument for this function, yeah, and now if I want to sample from here, I use function sample, built-in function sample, and as an input argument x, I take bonds which are provided by the user. Yeah, and at this moment let's focus only on one roll, and yeah. At the end, I write return and the object that should be returned as the output of using this function. Yeah? So if I type this, I will get an error at this moment. Why? Because first we have to load this function to the memory of R. Yeah? So here there is no error, and now hopefully there won't be error, and yeah, you see, it works. Every time I run this function, I sample from x's, which here is between 1 and 6. There are some weird RPG games, yeah, where dice have much more many sides. Yeah, so for instance, here we have, and so we can replicate the behavior of one dice. Yeah, but if we want to instead to throw two dice, here we should provide size equal to 2, and also the realization of one outcome of a die is independent from the other. So it means that in particular I can sampled bonds can be exactly the same for both dice. Yeah, so this means that replace should be true. Yeah, and if I load this function once again, so I redefined this function, here, will I get error message or not? Yeah, no. So here we have, as the outcome, we get the vector of sampled bonds. Yeah, and in our exercise, we are interested in sum of those two realization of two rows. Yeah, so we will have something like this. Yeah, and here we should get only one number. Yep. Okay. Yeah. So again, if I don't provide input, it takes the default option. If I provide some I want to generate some different object, then yeah, it is. Yeah. Okay, so now let's talk a bit about return command. So here in the return command is used inside function, and while it's not obligatory and it's only optional, it is recommended to use it. Yes, so now I will show to all of you what are how functions work without return. Yeah, so return inside functions, and let's create function fun1 with argument y, and here we have two lines of the code, and if unless there is return inside the function, then by default what is returned by the function is the very last line. Yeah, and in this case we will have fun1. It will be 4 times 3, not 4 times 2, so we should get 12. And yeah, we got 12. Fun1. Yeah, it may be the case. Yeah. Okay, and so what happens if we create a very similar function, but we will explicitly write what should be returned? Yeah. Fun211, and we get 2 times. Why? Because here we explicitly provided the object that should be returned. Yeah, and overall this return is not required, but I really advise to use it, because yeah, for such a short function it doesn't make a big difference. Yeah, but if the structure of your code will get larger and larger, then writing in an explicit way what is returned is a very good practice. Yeah. Now suppose that we are interested in the distribution of realized outcomes, realized sums. Yeah, and some sums are more likely than others. For instance, outcome 12 can be only achieved if we roll 2 dice with bonds equal to 6. On the other hand, if we take outcome 7, this can be realized that one die is 4, the other die is 3, one die is 5, the other is 2, but also the order is important, and the first die can be 2, and the second die then can be 5. Yeah, so there are much more many possible realization that gives rise to 7 than in the case of 12. Yeah, and in this exercise we would like to identify which outcomes are more likely than than others. To this end, we can use our function roll2 and run this many times. Yeah, it's not the most convenient way to do it and not the smartest way. So now we will use a function called replicate. Yeah, and this function takes as an input number of replications and expression that we are interested in, that we want to repeat so many times. So in particular, if we want to compute, we are interested what's the result of this addition, 2 plus 2. I hope that all of us know that it should be 4. Then if we use replicate 10 comma 2 plus 2, it will be computed 10 times. For deterministic function just like this, yeah, nothing changes. If anything changes, it would mean that it's something weird with our function. But deterministic function. But on the other hand, in our example, if we roll our dices 4 times for every realization, most likely we will get different results. Most likely or not, yeah, but this is random, yeah, and it's possible that we have different outcomes. So now we can roll, we can run this function 10,000 times, yeah, and save all those results, assign all those results to new object roles. Those are realizations, but we can use function hist to plot the histogram of realizations. Yeah. So we see that the frequency of those of results, yeah, the result that is at 7 is the most likely scenario, while 12 or 2 are the least likely scenarios. Also, similar thing can be characterized by using function table on our object roles. Yeah, so here we have exact numbers. Yeah, and yeah. Now we will talk a bit about data structures used in R. Yes, so and there are several data structures. The one that we already know are vectors. Second, there are matrices, arrays, which are extension of matrices to dimensions higher than 2, and yeah, there are also lists and data frames. Yeah. So we will discuss all of them, yeah, and let's use an example of die from previous exercises. And now, yeah, as we said before, this is a vector, yeah, and because this object is created with C, command C, concatenate, yeah, and how can we check whether this is a vector or not? There is a type of commands that start with is dot and type of data structure. Yeah, so we want to check whether this is a vector. Yeah, and it returns outcome true. Yeah. At the same time, if we check whether this is matrix, we receive negative result. Yeah. And if we want to create matrix, matrix is an object that has rows and columns. Yeah. So here we can create matrix X with n rows, and let's say that we want to have 2 rows and 2 columns and 3 columns, and the content of this matrix will be copied from vector die. Yeah. So here we have X. Yeah, and number of rows is 2, number of columns is 3, and elements of this matrix are elements from the vector. And notice that here in the matrix, here we have how this is loaded is that it is column wise. Yeah, so the first element is the first element of the first element of from the vector is the element in the first row and in the first column. The second element of the vector is the second row and the first column. Yeah, and so on. Yeah, yeah. Actually, also what is maybe not that important, yeah, but it's good to know, yeah, that if we provide number of rows and vector, R pins down what's the number of columns, such number of columns that this vector can be used for this number of rows. Yes, so here if we have 6 elements and we want to have 2 rows, then only can be 3 columns. Yes, so that the overall we will have 2 times 3 elements, which gives us 6. Yeah. If on the other hand, but what is important is that the length of the vector that we provide as an input must be a multiple of both number of rows and number of columns. And for instance, if we provide die and row equal to 4, we will get an error message here, because there is no integer that would there is no such a number of column that such an integer number of column that n rows time n col gives the length of the vector. Different data structures exhibit some attributes that describes the details about the structure of this data. Yeah, so the default object in R is a vector. Yeah. And this yes, so this, as I said, so this is the default data structure in R. So it doesn't have any additional attributes. But if we take, for instance, our matrix X here and we write attributes, it basically, yeah, here we see that there is additional attribute dim, 2 and 3. So essentially, to be very precise, X, how X is seen by R, that there is some vector with some additional attributes, in this case dimensions, and this allows R to translate the vector to the matrix. Yeah, so everything is in the memory of R is stored as everything is a vector for R. Yeah, but if we provide additional attributes, just like in this case dim, then we can change this to different type. Yeah, and yeah, so So yeah, and we can create our own attributes. Yeah, so there is one of example of attributes are dimensions, but also another example are names. Names are important for lists that we will discuss soon. Yeah, but for a vector, here we see that there is no description. There are no names for elements. Yeah. That being said, we can assign some elements to the names of some elements to the names of in the vector. Yeah, and then we can write 1, 2. We need a pool. 4, 5, 6. Yeah, so each element of vector die is associated with some name. Yeah, and die. Yeah, and now before we had the vector, and now we have additional each element is associated with its own name. Yeah. So now we can call the different elements of the vector using two ways. The first and the more, I would say, the default way to call certain element of the vector is by using indices. Yeah? So suppose that we have vector this. Okay, and suppose that we want to call only the 10th element. The 10th element will be here 29, I guess. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, and if we want to call this specific element, the element which is the 10th element of this vector, we use square brackets. This is important to remember, not normal brackets. Normal brackets are reserved for functions, and here we use square brackets, and yeah, we get this element. If we want, yeah, that's this option always works for all vectors. If we want to call the very last element, we can use, so inside here, instead of indices, we can use some functions. Yeah, and in particular, if we want to take the very last element, which is, there are 401 elements here. So if we want to take the very last element, it's enough to use length, a guy which has position of the length of the vector. So automatically by construction it will be the last element. Yeah, and here we have this. The second way to call certain elements of the vector is by calling by the names of those elements. Yeah, and in our example, so if the vector has names, just like our vector, so still, if we want, we can call it using indices. Yeah, but at the same time, also we can use names that we provided before. We provided or some other functions. Yeah, and so for instance, if we type the name in quotes and then square brackets, then we'll get this. Yeah, notice that also we can provide names whatever names we want, yeah, and even there, I wouldn't say that this is a good practice, yeah, but even we can use spaces. I think so. Let's check. Yeah, it works. Yeah. So now, so there are two ways, yeah, and to be honest, this calling elements by its names, it will be useful in lookup tables that we will discuss later. Yeah, for sure. Yes, so this is it. Yeah. And what if we want to get rid of those names, yeah, that we don't like those names anymore? So right now, yeah, there are two ways to do it. Yeah, the first way, let's create a backup of our vector. And one way to do it is just say that those names are null. So null is a value that says that something is not relevant. Yeah. So if we take our previous example, W, because we didn't provide any names, it has, those names are null. And now, if we have die and we make assignment to names, and we assign a value null to those names, yeah, we eliminated all those names, and we have our old vector. Yeah. Alternatively, and this is what I used yesterday, I guess, in my own research, not in this course. Yeah, is that so if we take our old vector here, and we want to get rid of this, there is function unname, and this eliminates names, but in the output. So now, so still those names are here. So now we have to assign the result of this function unname to our vector. Yeah. And now, yeah, this is our old vector without names. Yeah. So there are so overall there are two ways to call elements in vectors. Yeah, but the first one always works, and while the latter, it works if there are names. Yeah. So using a very similar approach, we can change different attributes, and so different than names. Yeah. And if we take our vector after getting rid of names, yeah, there are no attributes. Yeah, this is our old vector. Yeah, and now what? And now essentially we can change the dimension of this vector is null because it's not relevant. It has its own length, yeah, but there are no dimensions because dimensions are reserved for matrices and arrays. Yeah, and here, so if we assign that the dimension of this object die is to 3, it will change this, because we changed the data structure of of this vector, it is not, this object is not a vector anymore. It changed to matrix, yeah, and now if we type GimDie, we'll get this, and what else? Attributes die, yeah. So this is it, yeah, and also, yeah, before. So let me before our object was a vector, and now, yeah, if we type is vector die, you see it's not a vector anymore. It's a matrix, yeah. So as I said before, command is dot and data structure provides returns whether this object is of this type, yeah. And now I will make a very small digression about matrices once again, because I forgot about this, yeah. And so as I said before, we can create matrix. Matrix this way, yeah, and we provide the content of this matrix, and then number of rows, number of columns is computed as a residual part, and as I said before, those elements of the vector is entered by columns, yeah, and from time to time it is not the most convenient way, and there is option X matrix die and row, so the same the same syntax, but there is this option by row, yeah. If we provide this, now we have not 1, 2, 3, 4, 5, 6, but rather 1, 4, 2, 5, 3, 6, because everything is entered by rows, yeah. Yeah, so I think that, yeah, from time to time it may be useful. The very last type that I will discuss today, for me, are arrays, yeah, and it is super analogous to matrices. Here we have, let's say, we have matrix of vector of those elements. Sorry. We have this, and everything works exactly just like in matrices, but in arrays, an array is a generalization of matrices to k-dimensional case, yeah. And so instead of having only one dimension, just like vector, or two dimensions, just like matrices, here we provide argument dim, which tells us what is the length of each dimension. Yes, so overall, here the data entries, we have this, the length of this is 12, and now if we provide those dimensions 2 times 2 times 3, array. So I misspelled the command. And now I create object which is array, and it consists of objects with 2 rows, 2 columns, and there is the third dimension of the length 3. So this is this third dimension. 1, 2, 3. Alternatively, if we change still number of elements, the product of those numbers will be the same, and here we'll have only this additional dimension is of the length 2, so we have those 2 elements of objects with 2 rows and 3 columns. Overall, arrays can have even more than 3 dimensions. It may have k dimensions. But also, that being said, I don't. To be very honest, I don't use arrays very often, at least in R. In other languages from time to time, but not in R.